Okay, I would like to start this presentation with thanks to Professor Luga and also the staff of Beyond Festival. I need to thank the agents of Brazilian support for research that give me the tickets of the Lufthansa. And thank you for this invitation. I apologize, my English is very poor, but I hope you can understand what I'm going to say here. Well, I want to start making a small presentation of my academic background. I have 24 years of experience with audiovisual teaching and research in some Brazilian universities. I'm also director of documentary films, having made 15 films till today. The documentary, semiotics, and representation of reality were the subjects of my PhD studies. In the year of 2003, I started my studies of stereoscopy with the purpose of advancing studies on the documentary and the representation of reality. Today, I coordinate a research lab at the Federal University of Salto, Mato Grosso, Brazil. Mato Grosso do Sul is a state of Brazil. I'm also owner of a company for production of documentary 3D films, which is in incubation at the university where I work. Okay, the year 2006 began the project to equip the laboratory and to produce a documentary 3D film about a lake located within the university. The goal was to analyze the possibilities of three-dimensional representation of space through the 3D movie. The team was formed by Professor Zara Grubert, which is my wife, she's here, and for students of visual arts. Well, the production of a 3D film is more complex than a 2D film. In most cases, the possibilities of expression are determined by the type of the equipment that is used. To achieve the goals of the project was needed to build the specific equipment for filming. Was also needed to find a procedure for the film editing. After 3 years of hard work, some results were obtained. The laboratory was established, 2 rigs were made, designed a workflow for editing, and most important has been produced the film The Lake 3D, with the length of 10 minutes. This way, I would like to introduce every one of these results. Both rigs were made with aluminum plates. The rig of the left side is working with 2 cameras in position side by side, and which one of them is reversed. The rig of the right side is working with 2 cameras in orthogonal position and has a semi-mirror that divides by half the light. It's named beam splitter. Okay. The side-by-side rig has screws which controls the level of the cameras. Through these screws were made vertical parallax adjustments and also settings the rotation of the images. Through the camera's side shifting was made the adjustment of a horizontal parallax. The images were monitored with a laptop. Well, the beam splitter rig also has screws which controls the level of the cameras. The semi-mirror allows greater proximity of the axis lens. With this rig, it's possible to produce images of objects next of cameras with greater visual comfort. Monitoring of filming or the editing can be done with anaglyph images. The images used are known as gray anaglyph. The image of left receives the red filter and the right picture receives filter cyan. through anaglyph images, you can see without glasses, horizontal parallax and vertical parallax. You can also check the correct leveling of the cameras. Well, I do not intend to get in on the details of this image reading because it requires a great training. The information is in this slide. Using only the anaglyph image, you can check the positive parallax, an image located behind the screen. You can check also the negative parallax, an image located in front of the screen. So you can reduce or increase the distance between the cameras to obtain the desired effect. Improving the method to do this is subject to my current research. Well, 12. Monitoring the filming was done with a laptop. The output of the video camera was connected to a video card and computer USB port. Two softwares were used, the Stereoscopic multiplexer and the Stereoscopic player, developed by Peter Wimmer. Well, during filming are made adjustments of parallax, adjustments of color and brightness setting. One of the recorded image is reversed. However, in monitoring during the filming, the image is adjusted for the software, but just for monitoring only. Now I present the workflow. After the filming, the files were transferred to the computer. Files must have the parallax setting and also must be synchronized. Editing begins. It was edited first one side in 2D. After editing one side, the same editing structure was copied to the other side automatically. Then we had made an analysis of the quality of the images in 3D. Some new parallax adjustments was made, including floating window. Some special effects were produced after all. Other images were produced in 3D computer graphics. The compositions of images in 3D were also produced. After all these adjustments was started the final edition. The final cut was made in 2D on one side first. The structure of the final cut was copied to the other side automatically, the same way I made before. Well, finally, the two editing structures were ready. The left and right were placed in separate files. For distribution and exhibition, the two sites were organized in one computer file. For exhibition, the format of this file depends on media that it will be used. The end result was the main production of a documentary on ecology. We produced images in wild environment and in an urban environment. The documentary has several features of film language, quite used in 2D documentaries. So, with the domain of the 3D technology, we could achieve a good result in film language. Some conclusions. Not recommended check the filming through the 3D monitors. Not even check the filming through binocular viewfinders. The best view is made with anaglyph images without use of glass, like a graphic in an engineering monitor. Each one could be trained to do this. Viewing by a 3D monitor, it's only for the director or someone else for have an idea about stereoscopic image, but may not be used as technical reference. That's my point. More conclusions. The use of cameras with, only in the side-by-side rigs limits the film language. The use of beam splitter rig allows filming of objects located near the cameras, expanding the limits imposed by the side-by-side rig. The same for these cameras that have two lenses. Only one camera, but two lenses also limits. Well, the continuity of research on 3D technology, language, and documentary should treat the following issues: camera portability, automation and motorization of the rigs, computer systems for monitoring, a method for control parallax. Another point, finally, an important issue to be investigated is the development of an optical apparatus for shooting 3D with a single camera. This is an example of a system invented in 1942. I believe that there is a lot of inventions that could be recreated. No? Well, the idea is to do the evaluation of the influence of the technology in film language through the production of a feature documentary 3D film. Our proposal is the production of a documentary on the environment of the Pantanal. Pantanal, it's a wild region where the preservation of the environment live with the economic activity of cattle ranches. The Pantanal 3D will be a 3D movie, very complex, very demanding, to test the technology and the methods developed in research. Well, for those who are interested in learning about more the Pantanal, I got with me two movies I produced in the Pantanal. The most recent is the movie for children, The Dust, this film. After this presentation, if someone wants, I will be happy to show these films for who wants. Well, thank you. I think it's so. Maybe the lake 3D could be projected now. Thank you.